Two more. And then I think, good. And then. If the volume comes out, you just gotta lower your volume every time.
Yeah. Sounds good. Alrighty. Thank you everyone for being here in person for our lightning talks. We're kicking off our AHS research week with our lightning talks. And this was kind of a hybrid session. So thank you to everyone who's on Zoom. We can't see you, but we know you're here. We're gonna get started with our first speaker, Dr. Desi Bartlett. Can you hear us, Desi?
Yes.
Yes, perfect. So Dr. Bartlett is an UIC alumni. She did her BS in Kines in 1995 and MS in 1997. We welcome you, and she's going to give a brief introduction about herself and get started with talking about optimizing women's health in midlife, BodyMind Approach. Welcome, Dr. Bartlett. The floor is yours.
Thank you so much. I'm so happy to be here with you. As Dr. Bott was sharing, I'm originally from Chicago, and now I live in Hawaii on the island of Oahu. I've been in health and fitness for over 30 years, and it is my passion, and I'm so blessed to be able to do what I love every single day. Today, we're going to be talking about optimizing women's health in midlife, a body-mind approach, and what I call the big three. Now, before we jump into the slides, I'd like to just take you back for a moment to when you were in puberty. Think about like all of the different changes that were happening in your body. The skin changes, the hair changes, the shape of your body changes. Maybe even you had some like big feelings, if you will. This is very much what perimenopause is like, but in reverse. Instead of this surge of sex hormones like estrogen, progesterone, testosterone, instead what we have is this sharp decline that causes all of those same symptoms. But there's three that are most common, and that's what we'll talk about today, and how to mitigate those, as well as how to have a proactive approach so that as women are aging, we still feel good because we have a long lifespan ahead of us. And I truly believe that each person deserves to feel great in their body. Let's go to the next slide. So I always love to know when I'm listening to someone present, like what is their lens? How do they see this topic? And I have sort of three lenses, if you will, in perimenopause. First of all, I'm very much in this age range. You could tell by when I graduated from UIC. I am in my early 50s, and I wanted to understand what was happening in my own body. So much so that I went back to school for my doctoral research in perimenopause because there was not a lot of information about this until about 5 years ago. So it's an exciting field for sure. I work with women all over the world, teaching online courses, books, etc. And so I also want to make sure that I have the most up-to-date information for the women that I'm working with. And then finally, my own qualitative research combined education with yoga. What does that mean? It means that when women are educated about what's happening in our bodies, when we understand these changes and things like estrogen declining can lead to, osteopenia, sarcopenia, etc. If someone just explains to us what's happening, then we tend to have a feeling of more agency in our own bodies. And when we combine that with other proven techniques to help mitigate symptoms like yoga and fitness, then we've got something that's really practical and also cost effective because I can teach a woman about what's happening in her body in the course of a yoga class. And then let's move on to the background information, which is on the next slide. So what you'll see in the background information, of course, we make up as women, we make up about 50% of the population. And every single woman has either gone through perimenopause, will go through perimenopause, or is currently in perimenopause, unless there's a major surgery like hysterectomy or something like that. Now, the duration of this time can be anywhere from like 7 years to 15 years. It's sort of all over the map. And it can begin as early as 35 when a woman is very often still very much in her reproductive years. So it doesn't mean that you're no longer able to reproduce. It just means that the hormones are starting to fluctuate. And just like you felt sort of like during puberty, you might not feel like yourself. And that's what you'll hear from women more often than not. If a woman says, I just feel different, it's usually hormonal. And that's when we want to start to look at what else is she experiencing and really honor that. The most common age for menopause, I should define what menopause is. Menopause simply refers to one day in time. It is 12 months with no cycle. So everything before that is pre-menopausal. Everything after that is post-menopausal. That one day in time is menopause. What is peri? Peri, the prefix means around, like perimeter or peripheral. So it is the time around the menopause. Now, I'd like to take your attention to the next bullet point about research dollars, and this is a number that kind of makes me a little bit sad. Less than 1% of our overall spend in the US goes towards the research of perimenopause and menopause. That is not to say that that is the total spend for women's studies and women's health research. There is more, but the majority of the money goes towards pregnancy. Now, I work with women across the age span, and I love the pregnant mamas, and I truly believe that we deserve to have research across the span of our lives and not only during pregnancy. So this is something to look at. And then that last bullet point, it's important to find alternative and effective methods of mitigating menopausal symptoms. That's directly from my dissertation. Now, you might have heard the term HRT, hormonal replacement therapy. Some women do great with it, other women do not. For still other women, it might be cost prohibitive. So if we can have fitness and yoga and alternative methods to support this, then I think we're really doing women a great service. Now, what does this actually look like? On the next slide, you'll see what I call the big three. Now, the big three refers to the most common symptoms during this time. Number one, vasomotor symptoms. You probably know it as hot flashes and night sweats. Number two, sleep disturbances. So if you've ever had insomnia or woke up, several times during the night, you know how this feels. It is not fun. And then finally, what I hear about the most is belly fat, because that can be really, really disturbing to a woman when your body changes and you don't know why. So this can live as a cascade, meaning she might have a hot flash, and then maybe she goes to bed, and then she starts to have night sweats, and then she starts waking up all night long, and it becomes a cycle. And from there, the cortisol spikes. Now it's maybe like 6 a.m. She's got to wake up. She's perhaps in the sandwich generation. She's taking care of kids. She's taking care of her parents. Maybe she has a full-time job on top of that. So of course, this can lead to even more cortisol, even more belly fat. It becomes a vicious cycle, if you will. But there's a caveat here. Each of these symptoms can live individually as well. There is a constellation of up to 77 symptoms that can occur during this period of life. These are just the most common. So let's go over to vasomotor symptoms, because we're not just trying to fight or mitigate symptoms. We're also in some cases trying to prevent them when possible. So if she's sweating, profusely throughout the day, what is something that she can do to perhaps prevent it and or to treat it right on the spot? Now, I have been in yoga since I was 6 years old. My mother was a disciple at the Temple of Kriya Yoga in Chicago. And so I was gifted with meditation and pranayama, which refers to special breathing techniques, decades ago. And the one that I use with women having a hot flash is called Sitali, or you might know it as Shitali in Sanskrit. And I'd like each of you to try this right now. You are going to fold the sides of your tongue like a straw, and then inhale through that straw. And then you exhale with the mouth closed. Please do that 2 more times. This time, close your eyes. Inhale through the straw and envision cool air, like cool Chicago December air coming into your body. Close your lips on the exhalation. Feel the cool air circulating. And one more time on your own, sipping in that cool air and releasing. And you can open your eyes as you're ready. So this is the kind of thing that I offer. I just wanted you to have a little sample so you understand some of the techniques. Another technique might be something like, super refreshing cucumber water or something like that. There are absolutely foods and beverages that can help. Let's move on to sleep disturbances. For those of you who listen to a lot of podcasts like I do, you might know the name Andrew Huberman. Now, for sleep disturbances, and perhaps sometimes in the prevention of sleep disturbances, I offer a very deep form of meditation, which is called Yoga Nidra. Now, Andrew Huberman has taken this ancient technique and he's rebranded it as non-sleep deep rest. And basically what it is progressive relaxation, which if you're a Kines major, I know you know what that is. You go through the body and you help to relax and release each part of the body. That's what I do with the women that I work with so that I can help to calm their nervous system. If they are in sympathetic overdrive all the time, I need to get them back to baseline, if not all the way over to parasympathetic and rest and repair. So meditation is absolutely a very impactful tool that you can use. And then finally, let's just look at belly fat for a moment. You can read through this later on your own. You'll have the PowerPoint. But what I find is women my age don't know how to breathe. And I'll say inhale and they suck it in. And so I have to teach them about the mechanics of breath and inhaling, expanding your belly, feeling the diaphragm and the pelvic floor, moving down and up. And then they start to come back into their body. So instead of just being frustrated with like, what the heck is happening in my body? Now they have tools. So with that, let's move on to the last slide. And now that you've seen just a little like taste test of all of these different techniques, I'd like to share with you that, again, this is my life's passion, my life's work, so much so that I've created an entire system called the BodyMind Workout. And this came directly from my doctoral research. So I combined yoga, fitness, meditation, and nutrition so that every woman has techniques and tools at her disposal that she can use at any time, and she can share with other women around her, because that's really the hope here, that she can help to educate daughters, nieces, best friends, and we can all feel strong from the inside out. If you have questions, I would love to answer. I can't hear you. Y'all are on mute. There we go. Are there any questions?
Any questions from the audience? I'm just going to look at the chat. Thank you so much for sharing your journey and your work. Any questions? So I just had more of a question on just a little bit about, have you done, if you can talk a little bit about your research or any outcomes, or what led you to kind of this journey? If since we have a couple of minutes, you could share.
Yeah. So as you can tell from the year that I graduated UIC, I was out of school for almost 25 years. And when I was approaching the age of 50, as a gift to myself, I went back to school to do my doctoral research. And because I had seen so many of my friends and clients suffering with these different symptoms, I know that there's some way that I can help. And so that's why I went back, and I went specifically into qualitative research, because I wanted the outcome of helping people to feel better. And so what I found was that this combination of really understanding what is happening in our bodies and explaining it in such a way that a layperson can understand. You know, your estrogen is plummeting, your progesterone is plummeting, your testosterone is plummeting. Do you have more belly fat? They get that. And so that's really my passion, to bring all of the science into the field so that, again, people can feel better.
Alrighty. Thank you so much. Really appreciate it. Yes.
Thank you.
With that, we start with our AHS people. So let me welcome Dr. Camacho. Yep, ready? So Dr. Camacho is an assistant professor in the Department of Disability and Human Development, and he's here to share some of his work over the past years, and the floor is yours. So please.
Do I need this or? Or am I asking?
If I can,
That here?
yeah.
Yeah. Don't move, I cannot move.
You don't want it, you don't have.
Well, I was planning on doing
You could.
a dance routine here. All right, good afternoon, everybody. I was gonna dance, I'm not gonna dance. So I was gonna dance. But we'll make this quick. Hopefully this will be a conversation. I don't want to talk at you. Please ask me questions. Let's not make it so awkward. So my name is David Camacho. I'm an assistant professor. Today, really briefly, because as I understood, there were some undergrads or people who are trying to get into research. So hopefully I will push you and to the dark side. And yeah, you will be willing to go into that. So really briefly, I'll talk about who I am. I'll look into chronic pain. Yeah, hopefully it won't be too painful. We'll get into loneliness and we'll get a little bit into cognitive health as well in older Latino adults. And then ultimately the point here is that much work is needed and that we need you to come to this dark side. Okay. So who am I? Well, yes, I'll get into my education, but a lot of the knowledge that I have comes from lived experience. I was a caregiver to my parents. My parents were undocumented or illegal, as some individuals will call them. So very much my positionality affects the way I do my work and the type of work that I do. So I have a permanent tan, so brown, bilingual, I'm a gay man, so be it. And I'm a gerontological social worker and researcher by training. Okay. But part of the reason that I go back into this, my parents are no longer alive, but my mother used to say everything has a solution except death. So that really drives the work that I do. And there's a lot of work to be done with the aging population. So in terms of education, I'm originally from Southern California, University of California, Irvine, couple of masters from the University of Southern California, PhD from Columbia University, postdoc from Cornell Medicine. Yay. But a lot of the work that I did too before that was doing face-to-face therapy. So working with communities, working with minoritized communities, working with mental health, right? So these ideas of racial disparities or thinking about Latinx or thinking about these terms that we use are not just terms, they're lived experiences that I was through day in, day out. So to me, it's a lot more complex. These are important to me. So why should we care about older adults? Does anybody care? Oh, I know you do, but anybody care about the older folks? I mean, they do have one foot out the door, right? Except the wrong person doesn't seem to jump out. But anyhow, so loneliness is far too common. Loneliness is far too common. So when a person is not satisfied, not just being alone, but not satisfied with the relationships that they have, be it the quantity or quality of relationships, right? Chronic pain, experiencing physical pain potentially, and mental health. But chronic pain, 3 months or more. Usually, some people say 6 months, some people say a month. This is a problem in the field. And then we have Alzheimer's disease related dementias. David, you could talk a lot more about that, but dementia, right? It's a major problem. Cognitive health is a major problem. But what I keep asking myself here is, where are the older Latinos? We seem to be not represented in this literature, very minimally represented. And this is not just Latinos, this is other minoritized communities as well, right? So there's a lot of reason, again, thinking about poverty, minoritized communities, racial ethnic minorities are more likely to experience poverty, have lower educational attainment. These, again, are experiences that affect the way people experience health. Okay. So, of course, part of what I do is look at social determinants of health. Hey, if they give me money, I'll look into it. We take data sets that are available and we get into it, right? So I'm working with a team, we're looking at different social determinants of health. And of course, we find differences, right? Surprise, surprise, older Latinos are not a homogenous, right? But I can't believe I still have to say that. We have to prove it. At the end of the day, these are human experiences too, right? So I listen to what people say. It's not enough that I hate when people say, oh, they're erased. They don't have a voice. No, you're not listening. That's a very different story. So I choose to listen. I work with individuals. I work with community members. So yes, I'll hear things like, oh, the second one, me duele todo mi hermoso cuerpo. In other words, my entire beautiful body hurts. It must be because I'm getting older, right? So there are cultural factors, gendered factors, contextual factors in how people express health. We cannot ignore this. If we haven't noticed, not everyone's heterosexual, white, European descent, et cetera, despite the realities that some other people try to paint. So what do we see in the literature? As much as there are attacks on diversity, we look at the actual literature and where are we? Minoritized communities are hardly represented. I've been showing this in pain. We don't have very many psychosocial interventions, even though that's the recommendation now for chronic pain in older Latinos. We found very few actual studies being done here. Dementia caregiving, major issue. We found 9 randomized controlled trials. 3 of them included Latinos, and 1 of them was Cuban Americans. So not very representative. And of course, when we look at loneliness, Latinos are nowhere to be found. This is a problem, right? So a lot of the work that I do is, now we're getting into interventions. I was an interventionist, so we need to get these interventions out to communities. I'm working with the problem adaptation therapy, but of course, this comes with stories. These need to be adapted. These need to actually get out to communities. We know that a lot of people have difficulty in coming into the hospital. So Spirit, we need to go out there and give it to them and help them in their context. And that's what we're working on. And of course, thinking about their experiences. With this, I get disclosure of problems, long-term problems, like death and dying. We all know we're gonna die, right? Just saying. So death and dying comes up. Violence. This woman, you probably can't read the whole thing, but she finally disclosed to me after so many years that her daughter was actually killed by her husband. Domestic violence, was thrown off a building. She had been seeing a psychiatrist for years, had never told a psychiatrist. So we need that humane touch, right? The human connection. We need to invest time in this. And this is what I do. So ultimately, moving forward, if anybody wants to join, and this is not just for Latinos, is that in aging and gerontology, I listen, I question theory, I engage in practice. We need to do this, right? We need to look at the reality. This is not about diversity, it's the reality of the world. There are people from different countries, race, ethnicity, nativity, language, sexual and gender minorities fucking exist, sorry. But people are trying to erase certain groups, right? So we need to think about this, and there's much work to be done. So I'll say, yeah, that's pretty much it. I welcome you to come to the dark side. There's a lot of work to be done with older adults. Please come over. You don't have to work with me. You can work with David. And yeah, yay, that's it. Right through it. If somebody warned us, you should not go over time.
That will be me. Yes. So any questions? Wonderful. Do we have any questions?
Oh, no.
Yes. Hey.
I have a question. Thank you, David. These statistics are staggering given that we have so much modernization, socialization, apps, and ways to communicate and all that. What's the solution though? Like, do you have any? I mean, I understand you need interpersonal communications, people, but then I understand, yes, I am getting old. I know what death is. So yes. Yeah.
Well, I think part of the problem here is check. Part of the problem here is that we assume that people need to be with others to avoid feeling lonely. And it's not about that. People have very individualized causes of their loneliness. I didn't put it up here. We did a qualitative study where we looked at how people perceive their loneliness, right? And it was about people dying. It was about migration. It was about poor relationships with children, or my daughter doesn't pay attention to me. She doesn't come to visit me, or, the neighbor died, or my lover left me. You have to tailor the intervention to the individual needs, right? It's not about, most interventions are, let's go put somebody with 1,000 people. If those 1,000 people are not the people you want to interact with, it's not going to solve your feelings of loneliness. So we really need to get into individualized care for that.
Yeah, Bryce, do you need a mic or you can speak up? Yeah.
So my question was about the representation piece. So it seems like a lot of what you're saying is there's not a lot of information about different groups, you know. And one of the problems that I run across is the language barrier. So I'm wondering if you have any good ideas about like how to address that. Because like for me, like when I submit an IRB, I can just say, well, I'm not going to recruit people who speak Spanish because I'm not going to have an alternate consent form. It's really easy to do that, but what are some solutions that you think might help with that representation piece?
Well, one, it's not easy. That's one. You have to do that extra work, right? Which is part of the problem here because I have to do the extra work. Any Spanish speaker, I have to submit everything in English and then everything in Spanish. It's twice the work at the end of the day, right? And I'm not going to do it myself. It's going to take forever. So I'll hire somebody to do it, which means we need more funding to actually do the professional translation so that we can get through the IRB, right? And then there are also assumptions from the IRB. Like, oh, they're really vulnerable. You can't reach out to them. Or, I'm sorry, I hate this part. You want to give them a gift card. You need their names. You need their social security numbers. Have you heard the news? My peoples do not want to give that information. I don't want to have that information. This is actually a problem right now. So we need to modify the expectations research, the way research is done with certain communities. Yeah.
One more. Okay. Thank you. Thank you so much. And our next speaker is Dr. Stacey from the Department of Kinesiology, assistant professor. Thank you. Okay.
You okay with using a microphone?
I think I'm okay. Can everybody hear me? Okay.
If for the externals, if you can.
Or up here.
Yeah.
Okay.
Perfect. Okay. Welcome, Dr. Erin, and she's going to talk about hidden signals in brain blood flow. And she's also kind of relatively new to UIC, so welcome to her, and thank you for volunteering.
Thank you for being here. This is a new area of research, and the question here is so as I was saying, this is a new area of research for me. It's a question that has come about after hundreds, if not tipping into thousands of hours in the lab staring at physiological signals. So that's what I'm going to talk about, these hidden signals that we're not detecting in these populations that we should be. So by the time we clinically diagnose dementia, the risk, the impairments have been building for 20, 25 years. So that's a really long time to go undetected with some of these risks. And what we're seeing is it's very much vascularly driven, specifically kind of in the cardiovascular world, but that's translating into the brain. And post-mortem investigations of individuals with Alzheimer's disease, we see that upwards of 70% have vascular impairment, cerebrovascular disease. So it's very much tied to a disease that is not considered vascular, but it very much is. And now that we're stepping away from the amyloid hypothesis and getting into other areas, we're seeing that there's so much happening within midlife that is risk later on for dementia. So here is what I do in my lab. We use transcranial Doppler ultrasound to capture the middle cerebral waveform. We then take that signal and we pull out certain points. We use those points to capture mean velocities, or we calculate indices. And these indexes are using only 1 or 2 points of the waveform. But if you actually look at the waveform, you can see that there's actual structure there and there's differences. And we're not capturing that with these simple metrics. So with a collaborator at Emory, I'm implementing what was done in intracranial pressure and translating it into this waveform morphology quantification. And instead of 3 to 4 metrics, we're now able to pull out 25 primary metrics and then look at relationships to get 130 total metrics that we can then use to try to better identify. So here's some data. So this data comes from the University of Kansas Medical Center, their Alzheimer's Disease Research Center, which is where I did a postdoc. So we had 194 participants, 88 with early stage dementia and controls. So our standard metrics, the standard indices that we're going to typically use, we're only getting an AUC, or the area under the curve, of 0.5, which is no better than a flip of the coin. So you're guessing in reality. However, when we implement these more sophisticated metrics, we're actually able to increase that up to about 0.75 or 75% detection. And women, this works pretty well with our previous conversation. Women are 2 times more likely to develop dementia. It's definitely tied to menopause and what happens around the menopause stages. And so our question was, are there different signals between sexes? And we found that there is. So we're still able to differentiate these groups based within sex. But what we're seeing is the waveforms are different between sexes. So within women, we're more so looking at these peaks and valleys across the entire waveform, whereas within men, it's more so the second phase of the waveform that is different. And so the question then became, why? Why is there the difference, or what's showing up? And so then we wanted to look at phenotypes. Are there specific waveforms that are different within women, and does it relate to kind of anything? So what we see within women is we're actually able to distinct and identify 4 phenotypes, one being balanced, the other being around peaks, the timing of these different areas of the waveform. And then what I think is most important and probably most interesting is they have a specific waveform that is tied to pulsatility, and pulsatility relates to arterial stiffness. Arterial stiffness relates to amyloid buildup, tau buildup, cognitive function, a bunch of different factors relevant to dementia. However, within the men, we only see 2 phenotypes. They're either balanced or not, and the not looks very similar to each other. And so the take-home message is just our standard metrics that we're currently using are not, they're providing limited information. They have their purpose, but we're trying to put that purpose on everything, and it's not working. So these more sophisticated waveform metrics are pulling out other information, physiological information, that allows us to differentiate these people within different populations. And so that was kind of a lot. It's a little bit advanced, but if you take anything, basically these simple averages, these common indices are not capturing the complexity of this disease. And so just obviously have to recognize, as I said, this comes from the ADRC in Kansas. And then I am also funded by a K-12 board.
Thank you. That was wonderful. Do we have any questions? Yep.
Thank you, Stacey. So, oh shoot, I might have forgotten my question. Hang on. When ideas are innovative or not within a certain paradigm or the way we typically do things, sometimes they're met with challenge or, you know, a pushback. So this sounds newish. And so have you experienced that kind of, you know, no kind of thing? And if so, what have you heard and how have you tried to, or how have you like gone back against that?
Yeah, I would say the biggest kind of pushback is the measure I use. So TCD is not the most forefront. It's definitely in the clinic, but it has to be driven by a physician to be used. Although you can charge for it and all of those things. And we're very much caught up on using MRI and fMRI and these things. But what's not really fully understood is we're measuring different things. We're getting a better picture. So this doesn't replace MRI or anything like that. We're upstream from what MRI is showing. So we're able to add to the conversation and provide something that is different that help explain the things we see in MRI. I also like this measure. It does take some skill and practice, which I think is also reason why it's not used as much. But we get to use it in real time. So this is a temporal resolution as opposed to spatial resolution. So we're able to look at and manipulate the system in different ways and see how it's changing in the moment. So it brings more, so that's where the push is. And then obviously this is very sophisticated analysis. The guy that is my collaborator spent 10 years building out the algorithms to properly detect and validate this measure. So it's not used and given freely. So that definitely has some issues.
Oh, there's one more question.
Sorry, if there's time.
Oh, yeah. Maybe
Could we do it at the end if there's time? Okay, thank you so much. Appreciate it. Ready. Thank you again. And we have Kathleen, Dr. Sawada from Dr. Fuscher's lab, and kind of changing gears a little bit here, moving a little bit more into kind of movement sciences, biomechanics related stuff. Dr. Sawada, the floor is yours.
Mic check, mic check, mic check.
Talk really.
Do you want to talk in this one or do you want me to talk in this one?
Mic check two.
Okay. Testing. Hi, can everybody hear me? Perfect. Okay. You go back one. Okay, and I just used this, right?
Yep.
Okay. All right. Hi, everybody. Thank you for coming. My name is Casey Savada, and I am a postdoctoral researcher who's going to try to not take out all of these balloons, which are very beautiful, in Dr. Karma Foucher's lab. And today I'm going to be talking about some of my previous research experience, as well as where I am moving for my future research as well. I'm going to move over here. And I'm focusing on altered movement in aging adults with underlying conditions, specifically osteoarthritis. So human movement is very complex. There are a lot of different subdisciplines to human movement. And as you can imagine, this is very multifactorial. So the four primary areas that I'm going to be looking at are biomechanical factors, motor control factors, energetics, as well as psychological factors. So if you think about it, right, like we can measure the output of the person, biomechanical factors, but what goes into all of that, right? Like especially in something like osteoarthritis where pain, other psychological factors may play a role, it's not so cut and dry. So biomechanical factors, what do I mean? That's kinematics, kinetics, anything that we're quantifying human movement. Motor control is related to how the brain is then creating all of those movement patterns through primary motor cortex. And again, it's a lot more complicated than that, but how are the muscles activating together to create the output, which is biomechanics? Energetics are the physiological factors such as breathing, oxygen consumption, heart rate, all of these things, again, try to better understand that movement. Psychological factors, a little bit more self-explanatory, but specifically for the research that I'm talking about, things like kinesiophobia or fear of movement, and how that then goes into altering the movement patterns. So all of these factors are very interconnected. They exist separately, but they also interplay. And so we need a method to be able to describe how all of these methods can kind of come together and play a role together as well. Human movement variability is a method that is a motor control method that will be able to capture this. So if you think about it, in any given activity of daily living, we could reach for a target in an infinite number of ways. I could reach straight in front of me, the most optimal. I could reach around if there's something also in front of me, impeding my way to the target. But when does this become a problem, this excess of kind of movement strategies? It becomes a problem if it alters the task outcome, right? So again, variability may not necessarily be a bad thing because it means you have a bunch of options, but when it becomes a problem is when it hinders your task performance. So in aging adults with underlying conditions such as stroke and osteoarthritis, this can really kind of hinder that ability to be able to complete the task outcome and have that bad variability kind of come into play more. So stroke and osteoarthritis are both very prevalent in adults who are ages 60 and older. Even though they are two very different conditions, one is due to changes in motor control and the other is due to changes in pain and at the joint specifically, what they ultimately result in are being the leading cause of long-term disability in the United States, and ultimately reducing functionality for adults in that age range. So post-stroke, we know that there are things like reduced range of motion, as you see here with this individual who's reaching towards a cone. In both populations, osteoarthritis and stroke, there is this phenomenon. There's also broad weakness, asymmetric movements, and ultimately aging is compounded by these clinical conditions and resulting in some compensatory movements, as you see here, where the proximal body is forced to then reach towards the cone. In stroke, again, we're also seeing this decreased work area, as you see in this plot on the top right, where, again, they are constrained by the altered motor control and their movement is then altered as a result. Additionally, there's broad co-activation and decreased patterns of muscle activation in the trunk and arm post-stroke. Now pivoting to osteoarthritis, we're looking at kinematics, again, kind of looking at trunk posture. There's increased trunk flexion with more pain. And so essentially, you're looking at a kinematic factor, but seeing that it is dependent on this pain level and really exemplifying that all of these factors are interplaying. Additionally, previous work in the lab has shown that kinesiophobia does tend to scale with physical activity and that knee strength also scales with physical activity, and kinesiophobia can moderate or mediate these relationships, showing that, again, they're existing together. Additionally, the trunk angle that I saw in those previous participants, I also saw that there was increased energetic cost of that trunk, that strategy that they were using because of the pain. So the takeaway from all of this is really that, and this was also in a different study shown, that energetics were tied with physical activity. So the takeaway with all of this is that, again, it's all very highly intertwined. And so we need a method to be able to capture all of these kind of relations with one another. And it's key because ultimately they do seem to lead to decreased physical activity, which is a protective mechanism across populations. And so how do we blend all of these together? Again, coming back to this idea of movement variability. And so by capturing whole body movement variability, we're able to kind of wrap in all of these different factors. And so specifically, I'm looking at center of mass variability. And it's very important to maintain that center of mass because you have to kind of find the sweet spot between stability and agility. And you want to be able to have enough of that like agility to kind of adapt in a given moment. But also if you adapt too much, then that can also be bad and you can kind of lose your stability with that. So my goal is to be able to look at in osteoarthritis how these biomechanical, psychosocial, and energetic factors are influencing that center of mass variability. And so the long-term goal of my work is to be able to take this and see how this corresponds to physical activity. Preliminary work in the lab has kind of shown that some of these factors do seem to kind of have a relationship with physical activity. And then we can really address patient-specific factors and see, okay, if like for this individual, psychosocial factors play more of a role in mediating physical activity levels, then we can create more patient-specific interventions. And also what's very cool about all of this is that you can really expand it. I can bring it back to stroke. I can bring it to other Parkinson's, other clinical populations as well. And I really want to thank Dr. Fouché. She's been such a rock for me during my postdoc. I'm still fairly new, so be easy on me. And also my lab mates are freaking phenomenal. So thank you, everybody. I didn't take out the balloons.
Thank you so much, Dr. Sawada. Do we have any questions? And welcome to UIC as well. Yay. Yep. Go ahead.
Thank you, Casey. So with the movement variability affecting physical activity, do you know if it's like all like lifestyle physical activity, like any kind of movement they might do, or is it like specific to exercise where they're like, you know, structured, planned physical activity?
Yeah, so there's a couple of different ways that we're characterizing physical activity. We have we can use actigraph data and look at step count, but we can also do like self-reported scores. And so that's something too that like there's even a nicheness to how we're saying physical activity. And I think in order to like fully understand, we need to have both of those. So yeah.
Anyone else? That was my question. I was going to ask you, how do you capture physical activity? Because, you know, most people do use number of steps, but, you know, and the people we deal with, sometimes they're just doing gardening and they think that's physical activity. So thank you. Yes, you answered my question. Alrighty. So we have thank you again. We have our last speaker. We're kind of running on time. So we have Jessica Pitts, doctoral candidate from the Cognitive Motor and Balance Rehabilitation Laboratory. She's going to talk about her journey as a PhD student in the lab. Yes, and a little bit about her work.
Hi, so my name is Jessica. I'm a PhD candidate here at UIC, and I work with Dr. Bott in the Cognitive Motor and Balance Rehab Lab. And I'm graduating this summer, so today I just kind of wanted to go over my journey through aging research over the past 4 years, both as part of my dissertation as well as some other lab projects that I've been involved in. So my research has mainly focused on older adults with mild cognitive impairment, or MCI. MCI affects almost 20% of older adults, and it significantly increases the risk of developing Alzheimer's disease or related dementias. And MCI not only affects cognition, but it can also lead to gait and balance deficits. And older adults with MCI have particular difficulty maintaining postural control during dual task conditions or while performing a simultaneous cognitive and motor task. And these deficits can contribute to increased fall risk. Older adults with MCI are shown to fall 2 times more than cognitively intact older adults in daily living. And Dr. Bott has previously developed the 3 Ps model for fall prevention in older adults. This is based on first perspection, or understanding the causes and mechanisms of increased fall risk in older adults. Second, prevention, or developing evidence-based strategies which can effectively reduce fall risk. And third, prognosis, or predicting the individuals who are at the highest fall risk to allow for effective intervention. So we're now working on also applying this model specifically towards fall risk in older adults who have MCI. Most of my dissertation work has been related to perspection, or understanding how MCI mechanistically affects reactive balance control, which is the ability to respond and recover to unexpected perturbations like slips or trips. So we initially examined how dual tasking affects reactive balance control in older adults with MCI. Participants were exposed to these translational perturbations while they were completing simultaneous cognitive tasks. And we also looked at if specific cognitive domains interfered more with reactive balance control, like an executive function task compared to a visual motor task. And we found that older adults with MCI had impaired reactive stepping responses compared to cognitively intact older adults during all dual task conditions. But performance was the most impaired while performing a visual motor task. So this might suggest that impaired visual motor function could contribute to increased fall risk in this population. After this, we also wanted to understand mechanistically why older adults with MCI had reactive balance deficits. So was there an issue in perceiving the response and perceiving the perturbation and initiating the response? Or was the response just less effective, even though initiation was intact? So then we looked at EMG data from the lower limb during perturbations. And we found that older adults with MCI had delayed muscle onset latencies on the stepping limb. And they also had altered muscle synergies during reactive stepping, which are multi-muscle coactivation patterns. So this indicated that older adults with MCI might have issues with both the initiation and the execution phases of reactive stepping. And overall, conducting these sort of perspection studies helped advance my understanding of the biomechanical and neuromuscular mechanisms of reactive balance control and how they're affected by both aging and pathology. Moving on to the second P, prevention, I want to discuss some of the ongoing lab projects which involve training paradigms that target balance control, cognitive motor interference, and fall risk in older adults with MCI. So in one of Dr. Bott's ongoing clinical trials, we're examining the feasibility and effects of a dual task perturbation-based training in older adults with MCI. Participants are completing a 4-week training program, which involves repeated perturbation exposure under dual task conditions. So here you can see an example of one participant who's getting some slip-like perturbations while he's walking and also playing a visual motor task or solving some math problems. And we're looking at how this program affects volitional and reactive balance control, cognitive motor interference, and real-life falls compared to a control group who's receiving a standard falls education. Initially, we just assessed the effects of a single session of this training and found that it significantly improved both reactive balance outcomes and cognitive performance under dual task conditions. So this was promising that 1 month of training might result in even more robust or retainable effects. Dr. Rudd has also done a lot of work looking at exergaming as a form of training for multiple populations, and it's been shown to improve both volitional and reactive balance control, while also being fun, motivating, and cognitively engaging. So initial studies were conducted using systems like the Wii Fit or Kinect gaming systems, but Dr. Budd has also recently expanded to a cloud-based system, which can be accessed using only a web link. So this can make the system more portable and scalable. And over the past few years, we've been taking these games to different health fairs and community outreach events. Sorry, my videos are not playing, but there's some videos of some older adults having fun playing the games at different community outreach events. And then we're also collecting feedback from older adults on the exergaming system to continually make improvements. So we're documenting the facilitators and barriers to the system, as well as acceptability or attitude. And we've also started using these games during repeated balance training sessions in older adults and are seeing an improvement in scores over time. Okay, so lastly, I'll move on to the final P, which is prognosis. And this work is mainly focused on developing scalable and easy to use tools which can screen for MCI or fall risk in older adults. Our lab has been developing gait-based models which can predict the risk of having MCI or the risk of falling in older adults based only on a video of their walking pattern. And to make these models accessible and available for widespread screening, the FRATS app was also developed, where a participant or a clinician can upload a walking video and receive instantaneous results, like a 60% chance of having a slip-related fall or of having mild cognitive impairment. So here you can see an example of an older adult who's recording and uploading their video on the FRATS app. And then their body data would automatically be post-processed to capture their kinematic data. And this includes post-processing techniques that ensures these 2D videos are reliable compared to a 3D motion capture. And then within just a few few minutes, they would see their results, like the joint angle data, their gait characteristics, and the risk of having a slip or trip fall. And then hopefully we also will incorporate the MCI-based detection models into the FRATS app so that older adults could also receive their risk of having MCI. Okay, so that's all I'll talk about, but I just want to thank all of the members of the lab who have contributed to the lab projects and also Dr. Bott for leading our team. Thank you.
Thank you so much. I know we're right on time, but maybe one question for Jessica, if anyone has a question. Yeah, okay, Rice, go ahead.
A lot of the games and training that you have are like kind of virtual environments that don't mimic real life environments. So have you worked on developing like something that's like I'm walking down the street and, you know, like a bus is coming and I have to watch out for the bus and stuff like that?
Yes, I wish that my videos had played because maybe they would have looked more realistic. But there are also some games that it's like a video of you as if you were walking down a street and you have to step side to side and avoid different obstacles and stuff. But I think we're still working on incorporating different ways to make them more realistic.